Okay, so today's question that we're going to do is basically structural forms. So in structural forms, there are three types of things you can be asked. You can be asked for a hyperboloid of revolution, hyperbolic paraboloid, or this shape, which is a shell structure. Or sometimes it could be a combination of any of the two of the three. So in this case, we're showing a building that's in Dubai. The projections of the structure are shown. So basically here are projections. An isometric view to give us an idea of what it looks like is shown here. Now this is the important bit. It's produced by translating the generating parabola ABC in a vertical position. So in other words, the parabola is standing up along the parabola EBD. So if a parabola passes along a surface in a vertical position, then basically that's what we're talking about, shell structures. So generating parabola ABC, so again we know ABC is a parabola, is represented by the dotted line here. So this is basically, it's not exactly the end view, it's literally the parabola that was used to create this shape. B is the vertex of both the parabola ABC and ABD. So B is the vertex here, and B is the vertex of EBD here. Okay, so literally this would have been a parabola if it continued on, or a full parabola if it continued on. So it's basically cut off, so we'd have to figure out that. So it says, again, this is very important in terms of how they talk about it, because this is the order in which you should do it. So the first bit it says is draw the elevation. The second bit it says is draw the end view. So them two bits are fairly easy because we know how to draw a parabola, and we know how to draw a parabola here. This is slightly cut, so a little bit more awkward, but relatively simple. This bit here, when you look at it, for those of you that wouldn't have seen this question before, this looks like a parabola and this looks like a parabola. However, they're not parabolas, and the construction to produce them is not a parabola. So that's why they left the part plan for the end, to part C to do the plan after that. The other thing that they asked for is determine the true shape of surface AEC. Now we're not going to do this in the video, but just there's two methods of doing it. One is to project it 90 degrees this way, one is to rotate it down and get the true shape here. So because of that, we're just going to keep over a little bit to the right so that we have a bit of space to do whichever one of those methods we would prefer. Okay, so the last thing then is their scale is 1:100. So basically 6 meters, very easy, becomes 60 millimeters, 150 millimeters is what 15 becomes, 120, 75, and that's it. So it's not a massive question. We'd have loads of space. As I said, we'll keep over a bit to the right, and off we go. Now we could use the division line method for these, and as I said before in some of my videos, I would typically do that for an exam question just to make sure the examiners know how that I can use it. However, this divides easily by 5, and this being 60 divides easily by 5. And the same with these two measurements. So I'm not going to bother doing it for today's video, but if it was an exam question, I would at least do it on one corner, just in case they had part of the marking scheme was to show that I was able to use the division line method. Okay, so we make this set square. So our height that we have is 75, so I'll come down maybe 100. That looks good. Okay, so let's see if I'm straight there. Okay, so we'll come down about 100. And we'll draw a line across the page. And we want a little bit of space. Let's see, our width is 210 plus 120. It's not massive. So actually what I'm going to do is I'm going to go over as far as I can here. And I'm going to work back the way. Right? And that way it's going to give me as much space as I can for the bit to find the true shape at the end. So my height there, I marked my 120. My height is 75. I'll draw this up lightly. There's my point. I have a marker for 60 in the middle, and I'm just going to draw it like so. I usually use my T-square for that, but it's just the same because it's hitting off the visualizer. So there's basically my main rectangle for my parabola ABC, and I'll just label it there. AB. See, so you can divide it into whatever you want, but 5 is typically a good size, and in this case 75 divides evenly into it. So 70 divided by 5 is 15, and we have 60 divided by 5 is 12. So the easy way to divide by 12 is imagine 6, 6 and 0, knock off the 0 and add it to itself. 6 and 6 is 12, and that gives you what the division is. But you can bring in a calculator on the day of the exam, it's no problem. 12, 24, 36, 48, and again 15, 30, 45, and 50. So I have all my marks there. These points here will join to the vertex. So these will join up to part B. So these ones are all random angles, and the base ones go vertically up. Okay. At that stage I would typically number them. Locate the intersections. So I'm drawing an X there rather than a big circle, which some people draw and then makes it look like a football. And they show this as a dashed line just to show this generating. Now I'm going to draw it as a full line just so that it can be seen for the video. I'd probably come back my rubber and make it dashed at the end just to show it the same way. But this will just make it a bit easier to see. And then what I want to do is I can either mirror it across or I can repeat the method for the other side. So I'm just going to repeat the method, but a mirror method would also be fine. And again, depending on if you're looking at a solution from the State Exams Commission, you may see they use a mirror method. But as long as it's a valid solution, it's perfectly fine. So I'm not going to label them for the other side because I'm pretty happy with where they go. Okay, so I have my generating parabola, as they call it, ABC. I'll leave a gap maybe of about 20, and then I'm going to start to draw out my other bit. So I have a bit of 150, yes, and the height is the same. Okay. I'll just pull that across. Again, just because my visualizer gets in the way, that's why I had to slide that down. But there's basically my line across. So what I'm going to do is I'm going to take this as half a parabola, and I'm going to worry about the 60mm bits on the side after that. Okay, so this again is 75, so we do 15, 30, 45, and 60. So there's my points, and then 150 divided by 5. My knock off the 0, that gives 15. 15 and 15 is 30. 30, 60, 90, 120. So these will go vertically up. And again, if I want to label them, this is D, this is B, and we're going to have a point over a bit further, that's going to be E. We'll look at that in 1 second. So what I'm going to do basically is construct this half of the parabola first. Okay, so I've brought all my points there. Again, I'll call this 1, 3, and 4, and 1, 2, 3, and 4. And so that gives me that's a point, that's a point, that's a point, and that's a point, and I'll sketch it in then as best I can. So there's basically my parabola for the 150mm, my semi-parabola. So what I need to do is I need to go over another 60mm. Now as it happens, this point, because I split it this way, is 60mm. So I have two exact points that I know, one which is here and one which is here. So I'm just doing this just to highlight them. And I know that they're exactly 30mm from here to here, so the same point must be 30mm on this side, and 60mm from here to here, so the same point must be 60mm, which is the end of what it is that they want me to work on. So I'm going to move this down just so that I can draw a line straight across. And maybe I'll use a slightly different colour just so to make it obvious what I'm doing. I'll draw this across, and I'll draw this across. So if this was 30 here, this is 30 here. Now typically I'd use a compass to mark this, because they were an exact measurement, I'm just going to use this. So I'm happy enough with that. Move this back into its proper position. And there we go. And there's my 2 points found. So the last bit then, just don't forget the diagonal line that basically joins this to this. And there's my elevation plan. So I have part A and part B done there, the elevation and then the end view. So the next part it says is to draw the plan. So what I'm going to do first is I'm just going to literally create out the space that I'm going to need for this plan. Okay, so I need my 45 to be set up then to project down this way. Okay, now if you're new to this question, or if you came across on the day of the exam and you didn't know what to do, and thought, well, right, the plan is a parabola and the elevation, and the same as the elevation and the end are two parabolas, one left and right, you'd probably do okay, because as long as you create it out like this, that you have all the main points, you'll lose some for the method as to how you created it, but you'd probably do alright as an exam question. So again, I'd imagine there would be relatively, sorry, that should be A, sorry. Relatively lenient. The main thing that you need to do is get down, make it look what it looks like, right? And then if it's wrong, hopefully we'd learn from it, or hopefully we'd learn today how to do it. But at least if you'd got it down, you would get some marks. There's no marks for putting down nothing. So this is the unusual bit that's completely new to us. This is our shape. Okay, so go back to my 3D graphic. So basically, if you imagine this curve here, this one that's here, if you imagined it coming down the other side, is the only one that's the full shape of the parabola. So that's basically exactly the same as ABC. Right, but that actually, I don't know whether that 3D is drawn right, but anyways, that's basically that there. Right, and then every single one of these gets progressively smaller, i.e. a smaller portion. The parabola shape is exactly the same, but it's been moved down along it, so a smaller portion of it would be used. So if I just take my yellow marker here, I just sketch in what the last one would be like. So it'll be something like that. Okay, so that portion of the thing would be the same here as this. So it'll be the exact same shape, but I wouldn't have used it all. Now, unfortunately, the construction of a parabola doesn't allow me to just find the width and then the height and then use the same method, my diagonals, to construct the parabola here. You actually, because it would make a slightly different shaped parabola. So what you actually have to do is you have to use this parabola to solve how far apart this would be. Okay, so if I could find that width here, then I could find, well, right, if I could find that, I could find what that looks like in plan. So what I'm going to do first is I'm going to use my sections, and I'm going to start from, maybe I'll start from the smallest side. It might be the easiest way to understand. So maybe I'll start from here. Okay, so I'll use yellow because that's what I will use there for this. So if I look here, the height of my parabola here would be this yellow here, right? So hopefully that comes out okay on the drawing. So what I'm going to do is I'm going to take my compass and I'm going to say, right, well, if that's the height of it, and I might do shade this one in just for the sake of showing it. But for the rest, I'll just use color pens. But, sorry. Okay, so I'm just leveling out my compass. So if that's the height, so I'll transfer it using this method. So that's most accurate. So that height there is the same as there. So that means that that will be the height of the parabola that's going to be used. Okay. So that's that. And I'm going to shade this here. So if basically I had a chainsaw and I cut through this building exactly down there, that's basically the shape I would see at the end view if I looked in and seen that shape there. So if I know that there, then I know what the width is. So what I can do is, I'll draw my line here, and I'll take my width from my end view. I can literally go right, well that's the width. So therefore, there are two of my points. So my width there has given me that. Okay, so hopefully that makes sense. So what I'm going to do is I'm going to do the same with a load of different colours. So we're going to maybe take pinky purple for the next one. Okay, so again what I'm going to do is I'm going to take the height. And once we get used to the method, and hopefully we understand the method, but if we get used to the method, it just becomes sort of repetition of the same type of thing. Okay, so now there's my height there. So again I'll draw a horizontal line across. So again I should be using my t-square. I'm just using this just because my t-square is not a visualizer. So this was my height that I came down. So we'd call it H2 maybe. And that will have given me width 2. So whatever width that was there, that will be the width that I need here. Okay, so that looks fairly okay. Okay, so I need to extend that one up there. Okay, so this is W2. And again, I'm going to mark this as H1 just so that you can see, and this is W1. Okay, W1 and H1. Okay, so we'll take, maybe I'll use light green for something else. We'll take the light blue. Okay, so again, I'll take my height. So again, doing a nice neat drawing would be very useful here. So by doing a nice neat drawing and a bit of colour, this could be your revision page that you'd have to come back for all these questions, because they tend to follow the same format. The shapes can be slightly different. So this is H3, and as a result this is width 3, but the methods are pretty much the same. So they may give, it might be a parabola here in this view, but it's always a vertical parabola standing along thing, or it technically be a horizontal parabola as well. Okay, so okay, my this is just a small bit off due to my compass. So just in case you're wondering why is this a little bit closer on this side, that's basically the reason behind it. It's basically just actually this line here for some reason it's slightly off 45 degrees, so it's a little bit wider on one side. But the method is all the same. So again, H4 here. Okay, so we start to get very close to the edge now. Okay, okay, so that's basically our main points on the right hand side found. Just the last one. Okay, so we will sketch in our curve then. Okay, now the curve at the top is quite tight, so if I wanted to be a bit more accurate, I could take an extra little bit of a line here. But for today, we're fine. For an exam, that would be fine. But if I want to be more accurate, I can put another one here. So that's basically all the right hand side done. So now I have to do the left hand side. So the method is the same, or actually just before I do that, if I imagine this here, let's see, where is my pink that I was using? There we go. Right, so if I imagine this here was H5, say, this would have been the full height, therefore this would have been the full width. So hopefully that makes sense why that would be that way. So that would have been the full height if I took this and stepped it off, therefore that would have been the full width. That's technically why that would have worked as well. Okay, so what I'm going to do now is I'm going to literally take 2 more points on this side to figure this out. And I'm going to take this 2 sort of in between maybe here. So I'll use maybe a pink. And this is 60, so we'll go 20 and 20. Okay, so I'll start with this one here. So this time, instead of coming down to the ground because it's cut by the sloped angle, I'm literally going to come down between here and here. So I'm going to call this H6 and draw a light line here, so it's probably going to be quite large. And I'm going to do one maybe in an orange, H7. And that's probably going to be a lot smaller. Okay, so we'll take H7 first. So what I'm going to do now is again take this height. We're doing the exact same thing, but instead of having took the height to the ground and taking it to the angled part, that's H7. That's the smallest one I have so far. That's even smaller than H1. Okay, alright, H7 there and W7 here. That gives me the width. Okay, let's turn that down there. Okay, so W7. And then I do the same as the pink I was using for H6. So. Okay, so that's the height. Okay, so luckily it didn't coincide with any other measurement, just to confuse you. So that would be the width. That would be there with 6. Okay. Okay, so there's width 6. So then I have enough points to do this. And again, if I want to be a bit more accurate, I could do the last part, another one in between here. But I think that's more than sufficient, given the time we have to do the question. Okay, and that's basically how to do a shell structure. So I found the left hand side by using the shorter distances, the right hand side by doing this. I've used some nice neat colour, which makes it a little bit easier to read. And again, if I'm an examiner looking at that, it's very, very quick. As I said, there's a small inaccuracy in my question. This should look a little bit further in from this side, so it just looks a little bit jaggedy there. And then what I would do at the end is I would come back maybe with my Tipex pen and I would, or my rubber, and I'd put a little hidden detail line here. But we needed it to be solid initially anyways, because we don't know where these heights are going to hit and find our widths. So that's the question.